We've recently taken a look at sorting algorithms. Let us now change gears and actually take a look at something similar in a way, but also pretty different. You're watching episode 1 of Search Algorithms, the basics. Hello and welcome to the first episode of 3 in the Search Algorithm series. Today's video will come to you in 4 short parts. What we're gonna do is we're gonna take a very general look at searching, and then we're gonna look at linear search, which is the most basic form of searching. So alright, let us jump right into part 1. First, we must ask ourselves, what is search really? Obviously, you roughly know the answer. It's kinda like what Google does. You have a whole bunch of information and you search for the information you want. However, simple as that sounds, the actual logic driving Google is actually pretty darn complicated. I mean, for one, Google has to crawl through the entire internet to actually find and index stuff. It then needs to actually catalog all this data properly in such a way that when you actually perform a search, it will search through all these stuff and return to you what is most relevant. What we're gonna do in this series is we're only gonna scrape the tip of the iceberg and only off the last part I mentioned to you. That is the actual going through the data. Of course, Google also has to do other fancy things like partial matching, determining which results are more relevant, and all these things are actually beyond the scope of this entire series. So really, what we're looking at is just a list of items. We are given one thing to search for, and we try to search for it. That's it. So really, this format that I'm actually doing here very closely resembles what I'm doing in the sorting algorithm series. We're really going to be doing all the same things, having an input list, tracing an algorithm over it, and then determining how efficient the algorithm is using the big O notation. Now there is one thing to point out, the time complexity of search algorithms tend to require a little bit more explanation than that of sorting algorithms because there is always a little bit more depth. So yeah, just a heads up, this wouldn't matter so much in today's lesson. It will be more of an issue in next week's lesson. So now we move on to question, what really is the objective of a search algorithm? Now I know what you're thinking, there is that intuitive obvious answer, and that is to search for something. Yes, we get that, thank you very much. You see, that is not the only thing. We must actually think about how a search algorithm will respond if it finds something and if it doesn't. Now normally when you actually try to search for something, obviously, you want to know more about the item you give the system. To give you a very basic example, if I have an array and I told you to search for the number 6, obviously, I wanted to know more beyond just the number 6. You could tell me whereabouts in the array is the number 6, or you could tell me whether or not that number is present in the array. So of course, a search algorithm must take that into account and actually, give you a response that is meaningful. And with regard to meaningful responses, a search algorithm must also tell you when an item cannot be found in the list. Of course, this is also not a trivial task in the sense that you have to be sure the item is not in the list before you can say so. And what this means is the search algorithm actually has to gather enough data to come to that conclusion. So these are the objectives to bear in mind when writing a search algorithm. Now, since this entire series is pretty short, we're actually going to jump right in to look at one algorithm right now. Obviously, like everything we've ever done, we're going to start from the basics and try to work our way up. So let's start simple with linear search. Now, the idea behind linear search is extremely simple. Give linear search a bunch of items and tell it to search for something. It will just go from left to right throughout the entire input array and try to see if the item is there. At any point when linear search matches the item you've entered, it's going to tell you whereabouts that item actually is. If it goes all the way to the end of that array and doesn't find what you're looking for, then it can reliably tell you that the item is not there. How can we be so sure? Well, we've looked at everything in the list and we see that it isn't there. That is evidence enough. And that is basically it for linear search. It is the simplest, most intuitive algorithm, but unfortunately, it is also rather slow. The worst case time complexity for linear search is O (n). And the reason should be obvious to you, it has to go through n items in the worst case, and that is how long it takes. Now, for those of you who have watched sorting algorithms, you realize that ON is better than any sorting algorithm we've seen so far. And yes, that is true, it is indeed a faster process, but bear in mind that searching and sorting are two different processes, and within the realm of searching, ON is kinda slow. Well, that is pretty much it. We actually have enough information to wrap up for the day. In the next episode, we'll look for a way to make searching actually faster. If you have any comments, queries, or suggestions, feel free to leave a comment in the comment section below. Don't forget to check out the official Twitter account for this channel at twitter.com/0612tv. As always, I appreciate every like, favorite, and subscription you give me. But until next time, you're watching 0612TV.